Yeah, we're live. It's technically 7:26. I think we changed an hour there, but that's all good. Tonight we want to talk about fuel pumps, and Jimmy and I were talking about this, and long ago, and that I have up, the thumbnail that I have up is from okay, they had a dyno, so it's pretty cool. It was set up with all sorts of data logging so that they could run test not just fuel pumps but all kinds of stuff. They were the first guys I know that, and I'm sure other people did it, but they tested fuel rails, like pressure drops on fuel rails. They tested pressure drops on complete fuel lines, the whole, the line run from the pump all. Eventually they tested the along factory lines, because some of them are fairly small, 5/16 or something, or some metric version of that, 8mm or something. And so they wanted to see, because people were curious, like, how much power could I make with these size lines? And the reality is that even with a fairly small line, if you have enough pressure, you make a lot of power, which they were able to find out. But in that testing, we were able to test regulators and all sorts of things. But one of the things that we were able to test were fuel pumps. And that was very cool, because when I initially did my fuel pump, it was not very good. They were made. And the mistake for me, flow. So what I did was configure the fuel, as they had turbines. Now they don't have turbines. They don't have fuel flow turbines on the, they only have it on the carbureted stuff. So what I did was had one of the carbureted pumps feed the injected pump, and then we measured the flow rate. Imagine that's not accurate. The problem is that when you feed the pump from another pump and regulating the fuel flow, when you're feeding a pump with another pump and there's pressure between the pumps, the flow rate of the second pump goes up dramatically. So if it's just drawing fuel, like normally the fuel pump would be sitting in the tank, it's drawing fuel, it's spinning at a certain amount of voltage and all that stuff. That's how boosted pumps work. They increase the supply voltage. Test it, and this is the other thing, is that when you do the test, when you're testing fuel pumps, you have to test that at the same voltage. And that's where the Kenny Bell thing came in when they did that, is that they could test it at any given pressure, any given voltage. All that stuff can be stabilized, so you can get direct readings, and it could be set inside, so that it's fed the way that most of them are fed. You could also do, multiple pumps in series and parallel, all that stuff. So it's very, very cool when they got that. When we were testing all these stock pumps back then, it was lots of Ford stuff, because I did this for Muscle Mustangs. But we were testing the Focus pump, the SVT pump, the 03 Cobra pumps, just all kinds of stuff, Walboro pumps and all kinds of things, A1000s and things. And they all flowed way more than they were rated at when I did that initial test. And pressurized fuel source, which artificially increases. Now, you could argue whether or not, since we were feeding them the same and the pressure was regulated, that we're feeding both the pumps, that did we get the same, like, did they all change the same amount? So the relative distance is still what the relative distance is. We could argue about that. The only way to know is to go back and test it properly, which we did later on with the Kenny Bell stuff. And that worked out good. But what I wanted to talk about, one of the many things that Jim Bell was able to find out when he was doing that testing, is that, the problem that we have with a single pump is, and this is even back then, was even more so, because they didn't have these, 520, 530 liter per hour pumps. You run out of fuel flow on a single pump. So sometimes you take that pump, and so increasing the flow rate of the whole system, but also the nice thing is you increase the flow rate of the pump that's in the tank, the one that's feeding the other big pump, because now that pump is flowing with little or no pressure. So it's not having to flow now. So let's say it flows 530 liters an hour at 60 psi. Well, what does it flow at 5 psi, which it might have between these two pumps, or next to nothing? And so the flow rate goes up dramatically. So that's good. Obviously, the other way to increase it, like I talked about, you can increase the supply voltage. But the other way to do that, put another pump in front of it, is that you have two pumps. So you, instead of having a single tank in the pump, you have two pumps side by side. They go in the tank. Sometimes fitting them can be difficult depending on the opening that you have in your tank. But a lot of times two fuel pumps will fit. If one's fitting, two of them will kind of squinch in there side by side really nice. The problem with that, and this is one of the things that Jimmy and I were recently talking about, is that if you take two 500 liter per hour pumps and you put them together, and you can turn them on, they can always be on at the same time, which makes life harder on your regulator, or you can switch it on under boost when you need more fuel flow, but when you're just driving around, you don't need the extra fuel flow. And we'll talk about different things here. One is when we have these two pumps and they're both turned on and both have the required supply voltage, why sometimes do they not double the fuel supply? Why do not double the amount of fuel flow to the motor? And the reason for that is because these two pumps are connected usually in some sort of Y or T section that then goes up to a single feed up to the regulator or the rail, depending on how you have. But any or all of that from the pump forward up to where you're feeding the rail, because then the rail would be the next thing that in terms of possible in fuel flow. But the first thing that you would look at is that wire, that T fitting. And in a lot of these multi-pump hubs, when you look at how they plumb this fitting, the lid for this thing, because it has to fit in a certain size, the fuel flow of that thing has to be as much as all of those pumps are together. And if it's not, whatever flows the least amount is going to be the deciding factor for how much fuel you can supply to the motor. So if that lid, the way that they're teed or wired together, only flows 1.5 or 1.7 times the possible fuel flow, that's all you're going to get. If it can't support the fuel flow together, if they can't wire together unrestricted and flow all the way up to the motor, you don't get what you would get from two of those pumps. And so you got to make sure that the whole system is capable of the fuel flow of those two pumps. The other thing that I wanted to mention is, like we talked about, these have one pump running, because then under cruise and stuff, your regulator only has to bypass the amount of fuel flow from one pump. Now, ideally, the way that the OEMs do it is you also turn the voltage down to that pump. You turn the voltage way down so it's not oversupplying the regulator and having it, and having the rate, because the regulator has to be able to bypass everything that pump can flow, like at wide open throttle. Like if it can support 800 horsepower, your regulator, if you have one and it's not back at the tank, has to be able to bypass that much. Otherwise, you'll get an artificial fuel pressure reading, and you will either have too much under idle or not enough at wide open throttle, depending on how you've adjusted. And so you have a Hobbs switch that turns on that secondary pump. The problem with that, or the potential problem with that, is when you have one pump that's on and one pump that's off, if you don't have a check valve in that, a one for the second pump, the fuel will pressurize that whole system all the way up to the regulator, all the way to the fuel rail, but also it will backfeed the pump. You can't have it do that. You don't want to have it just flowing back out the other pump. So you have to have some sort of valve to stop that from happening. If they're both on, it's not a problem because they both have pressure. They're both flowing into the system. One of them is not going to backfeed the other one. If you have just one flowing, you have to have a valve on it. And then you switch that other pump on. under conditions that make it so, okay, now I'm using a bunch of this fuel, and then we're not taxing the regulator as far as return goes, because we're using most of that fuel. And so it's very important to understand all that. And these are all the little things. You're like, okay, yeah, I got this dual pump set up. And then you look at that, you're like, well, that's just 2 5/16 flowing into a single 5/16 line. That's 1 5/16 line. That's how much it flows. It flows whatever that one does. It doesn't know what those two do. And so you got to look at that and make sure that all of that's like, copacetic, that everybody's cooperating, that everyone's interested in like max flow. And so it's very important. We're kind of looking into the reason I bring this up, so Jimmy and I have meetings where we're talking about all this stuff, is that we're looking into that, because obviously a single pump is only going to take us so far. And with turbo LSs or whatever, you can go beyond, particularly if you add E85 to them, which means, hey, now we got to flow 20 or 30% more fuel, even at the same power level. So now we need more. And that's a discussion we're having. We're like, look, if we're going to do that, and it's going to be a dual pump setup, we got to make sure that, like all the things on the store, we have to test that to make sure that we know that the fuel flow of whatever assembly we would use to go down in there, again, you're limited by the hole size that's in there. Whatever that is, it has to support both of those pumps. Otherwise, it's kind of a waste of time. So we'll see what you guys got going on. I keep losing the sound. Yeah, it was saying I didn't have a good. Your device needs to restart to install updates. Let me see here. It's showing that we are connected. 2 is better, less heat, add redundancy. At what point do you think you should add a fuel cooler? I've only ever stuff. You don't have to worry about vapor lock as much. Internet's going bad. Also, did you see that Allison is splitting off from GM starting summer in 2026? GM dealers will be forced to scrap off all the Allison badging on remaining inventory. Dual pumps on your internet, 2 fuel pumps. That why the feed is common. Have you seen an individual pump per rail, or would that just have more headaches? No, you could do that. It just means that you have to run 2 lines. And the other line, they're just going to have to merge somewhere. But if you merge them together into a regulator, depending on how you do it, that can also work. Interested in doing an engine swap, but it's never been done as far as I know. I want to use a Saturn H6 in my 91 Camaro with a factory T5. I was wondering if you could ever build an H6 Whipple. Yeah, I mean, you can put a supercharger on anything, so you just have to adapt it. I have the stock pump in my Avalanche, feeding a Walboro 525 in a surge tank. That's good. The surge tank to fuel rails is at 44 psi. However, I can suck the tank dry. It was hot. You can suck the surge tank dry? Because a stock pump feeding your motor shouldn't use, well, at 17 psi, you might be able to use more fuel than that pump, than a stock pump, even at very low pressure. Because if it's feeding a surge tank, it's not under pressure in there. You might be able to, but man, how long are you on the throttle? Are you doing roll racing or something? Because if we assume that the thing is full, and then you get into the throttle, and then you have a full tank, plus what the supply pump is feeding in there, and you can drain all that out, that seems like a lot. Then you need to put a 342 or whatever in the tank too. Missing about 20% of what you're saying. My system is flex fuel with a fuel pump control module. I got to figure out how to make it a standalone. Putting Whipple on a Subaru 6 is absolutely possible. It will require a custom intake manifold. Honestly, I don't think I'd put a Whipple on that. I think I'd put a turbo on it, but on a surge tank fed by a single 255 or 340 in the main tank. Okay. Adapters are the way of hot rodding. Yep. Yeah, you can make all of that work, but a turbo would be just, because couple of days ago, you said a naturally aspirated 408 LS wouldn't fully utilize an AFR cylinder head. What could be done to make use of the head's capacity? Is boost the only way? You can build the right 408, but most of the stuff doesn't do that. Obviously, if you that's at the drag race level of stuff, or even like the cup level of engine building, where you're making, let's say on a 408, if you built a motor that's making 2 horsepower per cubic inch, you would utilize everything that 180 CFM. You would utilize everything that cylinder head has to offer. But it's a lot, though. I mean, it's a really, really expensive deal. It's more than just a 408. It's really, really high compression. It's lots of RPM. It's a dry sump. It's a short runner, kind of maybe a cross ram kind of intake manifold. It's all of the stuff to be able to get to that specific output on something that's that displacement. So that's expensive and hard to get to, and most people don't do that. I mean, some guys that are running all motor stuff for drag racing because they're in an all motor class or something like that, maybe they're doing that. But guys can certainly make 2 horsepower per cubic inch. In fact, they can do more than that, in which case they would be using that. But honestly, if they were doing a 400 per cubic inch or beyond, they wouldn't run that AFR LS3 cylinder head. They'd be running something that doesn't flow 380. They'd be using something that flows 430, 450, 480, whatever they could get. I do a Cobra 112 and a 450 horsepower isn't enough, then force feed it with a GT45 or a pair of GT35s. Yeah, I don't think that Subaru 6-cylinder is going to be, I mean, what is that, 150 horsepower motor or something? Will the bigger head be detrimental or just inefficient compared to what? We're talking about race motors and then regular motors. And the race motors are a whole different thing. That's not that sort of motor that's 2 horsepower per cubic inch is not something you're driving around on the street, and not a combination that it's gonna have so much camshaft in it that you're not gonna be, like I said, you're not gonna be driving it around. It's gonna be peaky. It's gonna be high RPM. It's gonna be what race motors are. Regular stuff, 600 horsepower to 700 horsepower, whatever, is not what most people drive around with. I mean, that's what most people drive around with. They don't drive around with 800 plus horsepower stuff. Tunnel rams also are good for that. They make lots of power. Chock full of tunnel rammy goodness. I have one pump that runs until hub switch in my charge pipe. Grounds a second pump. Yep, that's good. Hub switches are good. We used to do that also with the boosted pumps. We would turn the boosted pump on with a hub switch. Got a Kenny Bell on order for my turbo 6-liter. Found the limit of my 525. You're putting a Kenny Bell on an LS, and they're selling that? No matter the pump setter, aren't you not running full blast 24/7? You're not. Why having the second pump on a switch is a good idea. Richard, haven't been on in a while. Any updates on the turbo Tahoe setup? Yeah, right now it has the GTX 35 and the Truck Plus cam in it. And the 4060, I mean, he's still driving it around, but the 4060 is not happy with the boosted runs. It needs an 80. Right now, in fact, this weekend, I don't know if he got it done or not. He got the motor in the S2000, so it's a built-up kind of strokery motor. And so we'll do some turbo testing with that. I'm going to shoot for 25 miles per gallon, 600 horsepower on my next project build. What motor is that? That's certainly possible with boost. Hard to do unless it's but with like a turbo 4.8, that shouldn't be hard at all. Y'all should put a 6. I don't think Jimmy wants to do a 6L80. He's going to do a 4L80. And I think that's what most people would be doing. Planning on putting a cam in my Vortec 350. I was wondering about available piston to valve clearance. I want RPM, but I don't know how large I can go before the valves hit. You have two things to worry about on a Vortec 350. One is piston to valve clearance for a big cam, but also retainer to seal and an available spring package. You're going to have to cut the heads to fix both of those problems. You're going to have to cut a spring seat in it and then also cut the valve guide down and cut the diameter of the valve guide down, both the height and the diameter, I think, so that you can put a regular kind of seal on it. And then you could put a decent spring package on it, like maybe an LS beehive spring. And then you could worry about putting more cam in it. Kenny Bell sells a generic setup you can use on anything. They sell an LS blower kit. I mean, I know Jim used to. He did Rick from West Tech. They just put together a motor there with one on there, but I didn't know if John, who now runs that and runs, if he was going to continue with that. But I guess they are, which is good. 4.6 LH2 North Star engine in the C4. That's what you're putting in there? Okay. And turbos? Yeah, if the motor's stock, I don't see why you can't. So say you run a set of 320 pumps through an 8AN hose to a rail, or a single pump 525 through an 8AN hose. Advantage there as far as maintaining volume at high RPM loads. I don't really understand what your question is. Are you asking what the difference is between a single 525 and a pair of 320s? The pair of 320s should flow more, and an 8AN hose is enough to support that fuel flow under pressure of both of those, of either one of those. So the difference would be the pumps. I like that DW has the new 810 brushless small factory pump. Can output 1,000 horsepower stage pump. Oh, Deutschworks, okay. Can be activated with a hub switch. That is good. That is cool. I haven't seen that. 4L80 has been done a million times. The 0.666 gear combined with a 410 first gear will be a huge improvement over the 4. Yeah, you should certainly do that if that's what you're wanting to do. I have a 4.6 2-valve 570 wheel horsepower dual 400 pumps, 22 miles per gallon, 373 gears. Swap 2 triclo heads and hoping for more power and more fuel mileage. I don't know unless you raise the static compression. And is it 570 wheel horsepower? Is that a turbo thing? And what cams are in it? I got valve train figured out. I have 550 lift, just don't know about duration and LSA. Brandon, what are you trying to figure out? Boosted pump. I guess I didn't say that. Terry, what was your question? Oh, the boosted pump. Okay, I thought you were talking about the super. That's why I was confused. Yeah, boosted pumps fit on any electric fuel pump. It doesn't matter. Twin 400 pumps for 570 wheel horsepower. That's absurd. Yeah, 570 wheel horsepower you could do with that 4-pattern cam. If so, what were the results? I didn't test one, but the guys at West Tech did. And it's not something that you should do. The camshaft doesn't change what, and that's what they're trying to do. The single plane intake manifold happens with a single plane manifold, but you can't do cam timing. Sorry, keep bugging about AFR heads. I saw your article in the videos making 625 on a 408. I'm trying to get close to similar numbers in a street. Well, what are you asking about? The recipe for doing that is in the video. So if you take a 408, I thought you were talking about the 408. I thought you were talking about the AFR heads that we just ran with when I was out with Steve Morris. I thought you were talking about the new LS3 heads. So the AFR heads that we ran were cathedral port heads on the 408, and you certainly can do that. Or 245s probably, and we weren't making what those can make. But we weren't running a lot of static compression. We weren't running a giant cam. We were running a long runner fast manifold. So there's lots more stuff that you could do to make it less drivable. F1A Pro Charger custom Todd Warren's cams 11-to-1 static. I don't know what your thing was. Oh, okay. That's with the 2-valve thing? Okay. Truck back from the transmission shop for all 60 overhaul. They put a vet planetary and stock torque converter in. Not sure if they did tune on the engine, but it doesn't stall out in reverse. That's nice. It doesn't low speed crawl traffic like it did with the other converter. 916 Chevy, what's going on? Well, 260 or 275 rec port heads behave poorly on the street. No, I don't. The heads won't be a problem. Ability on the street is going to be more a function of the camshaft. L92 with 108,000 miles runs great for $600. Would you take this over LY6 for turbo application? What do you mean? Would I take it over an LY6? Those two motors are over an aluminum block for a turbo application. But for 700 or 800 wheel horsepower, you're fine with the aluminum motor. Dual 274 plus 15 or 1050. Yeah, there's no need to over pump it. If one of them will get the job done. It's like running two big turbo. Well, it's not like that really. Don't run too big. I find myself wanting even better boost response on this Omni, and not necessarily more power. I want the turbos to come on. I need to put the spring. But $600 for an L92 is $100. That's a really good deal for an aluminum motor from aluminium. Convert the old Mercedes to single pumps. Why are they running dual pumps on those? Biggest mistake you see people making when plumbing fill system is 90-degree fittings. Every 90 equals 10 feet of straight. I've looked at cars where the pump was 40 feet from the carb. Problems occur. I'd like to know where he got the information on the straight versus 90. And then the size of the 90 would have a big effect on that. On pure gasoline at low pressures, you add boost and EFI pressures plus ethanol dual 275s might support 600-ish. BPE 400. I don't see. Oh, I guess a dual plane is probably the problem. You would switch those numbers around. And I think that you have not a port problem. Like porting the intake manifold could help, but it's a design intake manifold. The first thing I would try is put a carb spacer on it and see what that does. Got the engine pulled out of my 08 Silverado, about to order cam springs, lifters, and push rods. Staying a cylinder wall, but you can't feel it. Yeah, go back and look at the original Big Bang motors. We had dark stains on the walls. Factory 4 has dual pumps. They run them in series. Okay. I never understood the purpose of running 2 fuel pumps in series. Does it actually increase pressure? I wouldn't think that that's beneficial if I mean, you could get an increase in that second pump because you're feeding it under pressure. And then, like I said, the situation is that the primary pump, if there's little or no pressure between the primary pump and the secondary pump, the flow rate of that pump goes up. And because it's feeding the other pump, the flow rate of that pump goes up too. But I don't know why they wouldn't just go to a bigger pump. Run 45s or sweeping hose curves when you can. No good. Almost every fuel rail that I've seen. Fuel pressure for Mercedes is 5 bar. Oh, so it's a direct injected thing? Is that why? Because direct injected stuff definitely has 2 pumps on it. It has a feed pump and then it has a mechanical secondary pump. Is a factory 30-pound injected buck truck? Yes, the 30-pound injector is not a problem at all. That's enough to support 8 times 3, 16, 448. That's enough to support 480, so that's enough. Pretty sure that the factory fuel pump will support that too. As far as electrical goes for, let's see. The larger 525 draws 20 amps at 60 psi, and the 320 each draw 10 amps at 60 psi. Well, and then the 2 pumps, the two 320s, if you have them teed correctly, so then what is the amp difference between those two? You're saying one's 20 and 2 of them are 10 each. That's 20. I'm putting an 88103 on as we speak. I was looking at the fuel pump requirements. I was leaning towards twin Holly 450s. An 88 is pretty big. How much power are you trying to make? That being said, wouldn't 2 pumps make sense to stack? Only, I mean, if that's what your metric is, are you worried about is that a concern? Will your electrical system not take that? Just got my car off the dyno, 2020 Mustang. Coyote, 85, 21 PSI, 274, 2 pumps, FIC 1650s, 1,000 wheel horsepower at 21 PSI. Okay, the motor is all stock. That's good. So that's, what's one of those things make on the, it's got to be making stock probably. It's easy to make a pump flow low pressure to high volumes, cheaper too. You also don't need much capacity in the pump right next to the destination. I had issues with fuel slosh in my 525 and my stock. The old Mercedes were KE jet. Yeah. Run an air motive 2000 with a Magnafuel 750 that comes on at 7-pound boost. Works good for 1600 on E85. That's nice. Just put LE47s. My voice is cutting out. I wonder what's going on with the internet. Amps, that's the problem. 18 amps, get 2 of them. And we're over 30 amps. Showing the internet is working. What's going on? But I did get an error message on here. So once it starts out being unhappy. Tricky poll. Would you choose to run one big EFI pump over 2 smaller pumps? Prius Mafia. I know. I'll have all the clips in chat. I have dual 340 setups on my Nova, running one right now. Rebuilt 6-liter. Those old Bosch pumps are tough to get now. So many fakes floating around, having fake fuel pumps. Yeah. I know. I'm going to have to replace those in my Mustang. Although I think I have an aeromotive system that's sitting there. It's been sitting there a long time. Single point of failure is better. But then you do have a spare. Like the beehive spring argument, the dual spring versus the beehive spring, that you have the secondary spring to help close the valve. So that you don't break something. Two-thirds, one-third, going the big pump route. One big pump and 2 small pumps are not safe. Need 2 large pumps for safety. Back in the Mustang days, we had a 55. Might have been a 155 back then, feeding one of those Bosch pumps, a Bosch turbo or a Porsche turbo or a 928 pump, I think. How can 2 fuel pumps in series increase fuel pressure? Well, the fuel pressure is determined by the regulator, not. You might be asking about fuel flow. I went over that just a minute ago. I would think 2 would be better. If a failure happens, you still got 1 to come get home on. Anybody run the injector dynamics pump? I don't think I've tried that. For the and then they switched to the brushless pumps. That's where those old Bosch pumps can suck the tank, collapse the tank. We didn't have that problem. I even had a bypass around it with a check valve. The guys from NL put that. I was talking to Dale about that when I had them on for the compressed air supercharging guys, because those are the guys that started NOS, and they hooked me up with that because they used that as their kit for the nitrous that they did on 5-liter Mustangs, and it worked good. Yeah, Thompson, if you feed a pump from another pump, the flow rate of that pump goes up, and then the pressure between the two pumps goes down, increase the fuel flow of the feed pump. So both of them, the flow rates of both those pumps go up. Get your return lines messed up, and your fuel tank will look like that submarine. That's not good. Went for a ride today, but did not see any turtles. I was sad. And not very much out. Didn't see lots of, normally we see lots of squirrels. Sometimes we see deer, turkeys, all kinds of stuff. Lots of people, lots of dogs, which was good. Like to see people out there walking with their dogs. So we got 2 more minutes. We'll cut it a little short because we're having on here. So the no's are catching up. 54.46. We run a regulator on the rail. We run an FPR. So whatever the second fuel pressure regulator you run, that's the one that determines what's happening to fuel pressure. 10 AN feed traps to an 8 AN fuel pump. I remember seeing a problem with that too. Somebody, I think it was Chad and Daphne's wagon. The feed that he had going to the pump was really, really small. And so it's not, it was starved for fuel flow. We have the return regulator set to 6 bar under boost. Okay. That's a lot. Why are you running so much fuel pressure? I'm curious. So we'll end our poll. 1 minute. So you can see there's 1 minute, just in case you can't hear me. Turbo M104. Okay. I'd run big brushless if the budget allowed. Yeah, those are nice pumps. The air motor brushless stuff was really nice. We didn't ever have to worry about fuel supply, basically. Yeah, the audio. Hopefully, the audio is good. I think I'm going to put a 255 in the Sprint. That's going to be more than enough. We're looking at the brushless. How complicated is the brushless controller? We don't even run the controller. When do you think turbo kit will be ready? I don't know yet. Our brushless, the PWM control pumps where it ramps up. I think it's controllable. We don't do that at West-Tech. Although for a long time, I remember bringing my Kenny Bell boosted pump over there when we had the regular A1000s for the dyno. I remember putting more voltage to that so that we could get enough fuel pump for some of the higher horsepower stuff that we were running. Yeah, we're still working on the turbo kit because we're having a casting done. And we just figured out something about it today, which might be really, really cool. Sometimes you learn stuff. I left and restarted the YouTube app on my phone, and the audio issue is now fixed. See, that's what you got to do. Turn everything back off and turn it back on. Do we have any Gen 5 guys out there? Are there any L83 or L86 or LT1 guys? Maybe for the Gen 5 guys, we just bring back one of those, the old Callaway, like, micro fueler things. Gen 2 LT4, that's good. West Michigan, home Steve Morris, nice. Little chassis down here, buddy. How's like sweet. You guys are making tunes on. Yeah, it works good. And that's all of that's actually being redone. A Delhi and L8T truck. It's never been task of it. Sometimes having, like, that's why my thing is stock, because I mean it's beat up. It's got cracked windshield. It's got a bad door handle. It's got all the paint is coming off of it. Missed you by 4 miles. That's pretty close. So I think I had to drive, I don't know, a couple of miles over to the hotel I was staying at. Have you found overall that fuel pumps don't last very long? I haven't found that, but I haven't done long-term testing on them. The L8T, that's the Stroker Gen 5. It's a big truck motor. Because I guess if you're going to do the only thing better than a 6-liter or a 6.2-liter truck motor is a 400-inch one, right? Interesting split in the one large pump or two small pumps. Is it the power draw thing? I feel it just introduced another point of failure. Do you run the external Bosch 044 pumps on your car? I did run one on my Mustang. I mean, this was back in the late 80s and early 90s. It's still on there right now, as far as I know. I haven't seen the car for a while. The L8TS toothpick rods. Yeah, that's what Brian sent me. Brian Tooley sent me a picture of the factory rods, and they're not impressive. Especially for I guess it does what they. But I only ran one of those pumps. We ran a feed pump feeding that as an external pump. And I think it was an 044, I'm guessing. I didn't know Bosch part numbers back then. Pump. L8T consumes a lot of oil. You worked on the cannon valve heads. He wants me to try a set of those because I told him about the 4.8 test that I want to do. He wants me to put those on it. And then when I mentioned the Brian, when I mentioned the Steve Morris AFR test, our heads are better than that. I'm like, wow. Yeah. Yes, sir, Bob. On that note, for us to force a swap over to E20 and everything's falling apart. Yeah, that's not good. On that note, it is time to go, but I did 2 today, so that's good. And I will be back tomorrow.